We are finishing with the trigonometry and the analytical geometry now. So on Thursday we're starting the functions which will be in book 1. Okay, so Thursday you bring book 1. Alright, so in Afrikaans class as well, the kids said that they had trouble finishing in time. That is a thing about paper 2. Because there are many different ways of getting to the answer. With algebra, normally there's only one way. You can either do that way or you cannot do the sum. Right. But with these ones, there are many different ways that you can get to the same answer. But if you don't know your work well enough, you haven't practiced enough, then you will choose to use a method that will take you 5 minutes, but you only get 2 marks. And that's why you are not finishing. Okay. Having said that as well, this was not a difficult test. There were no tricks in this test. In fact, if I compare this test to the tests that I've given in previous years, this was a joke. Okay. There really wasn't anything funny in this. And that is what is worrying me, because you don't know the basics. I said to the Afrikaans class as well, it shouldn't be necessary for me to give you old question papers and beg you to come and show me where you've done it. You've got that full yellow book that you can work out. In a November question paper, the work that we have done includes the questions at question 1. That's around about 30 marks. The questions at question 2, that's normally about 20 marks. Then in paper 2, we've done analytical, which might be 40 marks, but 20 of it is straightforward, just calculating a gradient or a midpoint or whatever. Then we've done the trigonometry, of which we haven't done everything. That's also just about 30 marks at the most, not even. And then we have the Euclidean geometry, which in a question paper 2 can be 3 questions. Right. That brings us to 5 things. All you need to do is to commit yourself to take 1 question each day. To start your Monday, take your yellow book, work out question 1. That's all for day 1. Day 2, question 2. That's all. Day 3, analytical. You don't even have to do both of the analytical questions, you can do 1. Day 4, trigonometry. Day 5, Euclidean geometry. When the next week comes, you start again. The next question paper is 1. The next question paper is 2. The next question, or that same question paper, second question on analytical. Day 4, the next trigonometric question paper. Day 5, which is Friday, you are off. You can spend that day doing some Euclidean geometry. By the time you write exams, you won't even have to study for mathematics, if you can commit yourself to doing that. And if you did a question 1 on Monday, and you saw, but I'm struggling with this nature of the rules, then you come to me, you say, ma'am, can I come and see you at break or after school or whatever? Maybe there's just something I don't understand that you can just help me with. I want to help you, but I have taught you. You now have to learn and study. I cannot do that for you. This is a decision that you need to make. And it's not something that I can do for you, or that your parents can do for you, or can force you to do, because in the end, it's in your hands. I had a learner in the Afrikaans class WhatsApp me on Sunday evening and ask, is the test of tomorrow on these old question papers that I hand out? The post-term work, that ones that I give to you for revision. So what am I supposed to do? It is not going well with us in grade 11 mathematics. And I do not know why. There hasn't been one time where we've done a part of the work where any of you have put up your hand and said, yo ma'am, I really don't understand this. And I don't think you have felt like that. I think while we are doing it, you are okay with it. But you don't go through the action by finishing it, by practicing it yourself. The biggest or the most general mistake in, I've only marked 5 question papers and I couldn't go on, is learners calculating the gradient and swapping the x and the y. Putting the x's at the top and the y at the bottom. Like, if I have parents here, they're going to ask me, can't we arrange for an extra class? Do you want an extra class to learn a formula? To learn that the y's go at the top and the x go at the bottom? You understand what I'm telling you? Because I don't know what to do. Because it's not in my hands. So you guys need to make that decision. The exam starts in 3 weeks. During these 3 weeks we have to finish the functions as well. Actually 2.5 weeks. There is literally no time to be doing revision. That's why I've given you these things beforehand. That's why I'm begging you, work out the papers. You have it. If you can't find a memo online, come to me. Say, ma'am, I did this, I can't find the memo. Can you please check for me? Can you help me? And then I can help you. With that first question paper, none of you have even realized that I said 8 squared is 16. Instead of saying 8 squared is 64. I made that mistake. The radius was supposed to work out to 17 and not 5. So I wonder, how much are you paying attention to? Okay, let's start. The coordinates of M, the midpoint of BD. Nothing to it. You had to know the formula. You add the x's, divide by 2. You add the y's, divide by 2. Then the two answers that you get will be 5 over 2 and 0. We'll go on now. So it would be 9 minus 4 over 2 and minus 2 plus 2 over 2. Or if you start with D, you say minus 4 plus 9 over 2 and 2 minus 2 over 2. Gives you 5 over 2 and 0. The next one says hence or otherwise. That means using your midpoint or in any other way. We wanted to show that that x is minus 3 and that y is minus 6. Alright, Now the two ways that you could have done it is you could have used the midpoint theorem, where m you have the answers of 4 over 2 and 0. So you're going to say x plus 8 divided by 2 equal to 5 over 2 and simplify it. And 6 plus minus 6 over 2, 6 plus y over 2 equal to minus 6 and then simplify it. Or you could have used the fact that this is a parallelogram, where you use the shortcut. So you're saying if this y changes from 6 to negative 2, this y is going to change from 2 to negative 6, showing that calculation. And if this x changes from 9 to 8, then this x is going to change from negative 4 to negative 3. But you had to show it as well. I just want to show you on the sketch before I show the calculation. You could also use the midpoint shortcut. So saying for negative 4, you had to say minus 5,5 to get to the midpoint, and then you do it with the x as well. Doesn't matter which method you chose. You know the shortcut methods and you know the calculation methods. You just get the mark for showing the calculation, not getting the answer. The next one was the gradient of BC. You had the coordinate of B, you had the coordinate of C, so all you had to do was substitute into the formula, which is y minus y over x minus x, and then you get 4. The gradient of BD, you had B, you had D, all you had to do was substitute into y minus y over x minus x, and then you get negative 4 over 13. The next question asked to show, so we are saying it's already true. You just have to show that DBC is not right angled. That means that angle is not a 90-degree angle. So 90 degrees means that the gradients, if you multiply them, you get negative 1. But I am already saying it's not 90 degrees. So all we need you to do is show why I can say it's not 90 degrees. So all you had to do was take the gradient of which you just calculated it, multiply it with the other gradient that you just calculated, get an answer, and say, but it's not negative 1. I already said it's not right angle. So that's why it's not right angled, because when you multiply the gradients, you don't get negative 1. Then they wanted the equation of AB in the form y equal to mx plus c, so you had to calculate the gradient of AB. Once again, normal gradient formula, y minus y over x minus x, then you get the gradient minus 2 over 3. Substitute into the equation, use your coordinate. You could use b or you could use a, substitute in there, and you get c to be 4, and your equation will be negative 2 over 3 plus 4, 2 over 3x plus 4. 1.7 was the first grade 11 work, where we asked you to determine if BD and a coordinate E are collinear. Now once again, different ways. You could have gone and found the equation of BD and then see if that coordinate E, if you substitute in its x value, does it give you your y value? Then you can say, no, it's not collinear, or yes, it is. But the shortest way, you already have the gradient of BD. It's minus 4 over 13. All you had to do was calculate the gradient of BE or DE. Doesn't matter. Just either B or D and E. And then you don't get the same gradient, and therefore you can say no, they're not collinear. If you got the same gradient, then we would say it is collinear. Okay, then we go to the inclination angle, and I also told you guys that you are going to get the inclination with the exterior angle. They don't ask it in grade 11, just a normal, what is this inclination angle? So I just want to put the sketch on there. You have the gradient of AB. You just calculated it, which can give you this angle. I'm somehow going to call it alpha. Can you all see that this is not an inclination angle? That is actually how you knew you had to use the exterior angle of a triangle or something. Now you could either have extended this line just down, or you could have used another horizontal line. Then that would also be alpha, and that would also be the inclination angle. Now, you didn't have the gradient of AD. We haven't calculated it before. But AD is parallel to BC, and you had already calculated its gradient, it was 4. So therefore, all you had to do, well, let me show on the diagram first. With that gradient, you will find this angle. And then these two, I call this one beta. These two are the opposite interior angles of the triangle, where alpha is the exterior angle. There it is. Okay. So as I say, I had the gradient of AB, so I just said tan alpha equal to negative 2 over 3, it gives me 146,3099. Then I say that BC is parallel to AD because it's parallel lines, or the gradients are equal because it's parallel lines, so tan beta equal to 4, so beta is 75,96. Then I subtracted the 2, and I got 70,3, and my reason is exterior angle of a triangle. Okay. Question 2 is the parallelogram KING. Now, KING already has all of the properties of a parallelogram. So when we did the quadrilaterals, I told you guys that you must especially know what is the difference between a parallelogram and a rhombus. What's the difference between a parallelogram and a rectangle? What's the difference between a square and a rectangle and a rhombus and a parallelogram? What differentiates them? So when I look at yes, I said. There. And then? Did you get the same answers? Okay, I will just check when I'm not. Okay. So the main difference between a rhombus and a parallelogram. With a parallelogram, we only have 2 pairs of opposite sides equal, but a rhombus has got 4 sides equal. But because we don't have I and G's coordinate, that doesn't help us at all. Okay. So you will remember I said to you, you cannot decide which property you prefer, because it won't necessarily always be there. So you have to know all of the differences. So the other difference is that with a parallelogram, the diagonals bisect each other, but they don't make a specific angle. With a rhombus, the diagonals also bisect each other, but they bisect each other perpendicularly. And that's what we had to use to prove that this is a rhombus. You have the equation of IG, which is a diagonal. But as it is there, you cannot use it, because it's not in standard form. So I had to get y equal to a half x plus 21 over 4. That 21 over 4, which is ugly, doesn't even bother me because I'm not interested in it. I'm only interested in the gradient of IG. Because if I have the gradient of IG and I can have the gradient of Kn, then I can see whether they are perpendicular to each other. And you guys saw that the question stated you have to show that it is a rhombus. So it is a rhombus, you just have to show it. Now to get the other gradient, I can just use the gradient formula, because I have both of those coordinates. So what I have here is IG in standard form, that's my first gradient. I calculate the gradient of Kn, I get to negative 2 Then I showed that a half times negative 2 is equal to negative 1, and therefore king is a rhombus, diagonals are perpendicular. Nothing more. And if you think about your question paper, about what you answered, you know how much more you answered, how much more you did, except for knowing what you have to do and then just doing that. And that's why you can't finish. Okay. Right, then we got to the trigonometry. That first one, 5 cos A plus 3 equal to 0, is exactly in your textbooks. We did that one in class. It was just the questions on it that was different. So you had to get your cos alone, then determine your quadrant. I said to you that this is the Pythagorean ratio that you don't even have to show because you know 3, 4 and 5 goes together. Because that's the one that we started with in grade 8. But you had to remember that it's plus and minus 4 for Pythagoras. And then you must decide, is it minus 4 or plus 4? And it was in fact minus 4. Okay? I also said to you that here they asked for sin A plus cos A. That cos alone is nothing. And A is something you are never going to find because you don't have a calculator. But that sin A is a fraction. It's the opposite side over the hypotenuse. And the cos is the adjacent side over the hypotenuse. And you have the opposite side and you have the hypotenuse. And you have the adjacent side and you have the hypotenuse. So that whole sin A is substituted with negative 4 over 5. And the whole cos A is substituted with negative 3 over 5. And you simplify to get negative 7 over 5. The next one was given as tan squared 180 minus A plus 1. This was just to see whether you guys remember that if it's negative from the quadrant, the square will keep it positive. You remember that? So therefore you got your first mark for realizing that it's still just tan squared tan squared A plus 1. Substituting to tan squared A, the whole tan comes out. Substituted with opposite over adjacent, and then you square it. Add 1, you get 25 over 9. 3.2, the one I told you even, I'm going to put it in the question paper. I told you. Sin 241. Now, what I've written here is what I've said in class as well. This must be an acute angle. And the total of the bracket must still be 241. Because you're not changing it, you are manipulating it. Right? So that's still 241. That's an acute angle. That puts us in the third quadrant, so it's negative sin 61 and therefore it's negative b. The sin of negative 119. The sin of a negative is the negative sin. 119 will be 180 minus 61. That's in the second quadrant. It's positive, but there's already a negative, therefore it's negative sin 61, and that gives you minus b. Then came the one that didn't want to work, which I told you will be there. Okay? It's always going to happen. Because now they are asking you for the sin of 29. And you don't have any information on the sin of 29. You have information on the sin of 61. So maybe you decided, I will try the cofunction. Then you say sin 90 minus 61. Do you see 90 minus 61 is still 29? Okay? That's in the first quadrant, it's positive, but because of the 90, it becomes cos 61. But now, you have the angle right, but not the function. You have sin 61. So that's why you draw the diagram. 61 is an acute angle, it's in the first quadrant. You use the one given. Sin 61 is p over 1. So it's opposite over hypotenuse. Then you do Pythagoras to get your adjacent side. If you had noticed and you see that that angle is the co-angle of 61, 29, then it's not necessary to change this to a co-function. You can use sin 29 because sin 29 is opposite over hypotenuse. If you use the co-function, cos of 61 is adjacent over hypotenuse. And it's done. Both cases gives you the square root of 1 minus b squared. I will open up now again. When you look at 3.3, you need to already see that this is a special triangle sum because of the nice values. There are only two Gogga values in there, and that's the cos 27 and the sin 63. But what you need to notice about those Goggas is that they are co-angles. 27 plus 63 will give you 90. Therefore, using a co-function would get them to be the same. But 120, nice round. 210, nice round. 315, it's the 45 one. And 540, you subtract 360, then it's just a 180. Okay. Remember, you just subtract and throw it away. So, 120 became 180 minus 60. 210 became 180 plus 30. 315 became 360 minus 45. I left that one. But if you decided to change that one, you had to leave this one. You had to leave either one of them. I changed this bottom one to 90 minus 27. I just showed you there, it's still 63. Because what was given was sin 63. So it's still sin 63. And then I said 180 minus 0. It's not necessary to say 180 minus 0. If you just said 180, that's fine as well. Second quadrant, so it's positive sin 60. I also warned you about putting in your multiplication signs so that you don't think you've got a multiple term at the top. Even I put in my multiplication signs. Third quadrant, negative cos 30. Fourth quadrant, negative tan 45. Cos 27, it's not special, I can't do anything with it. But because of that co-function, this bottom one also becomes cos 27, which makes it possible to cancel out. Cos 180 minus 0, that's negative the cos of 0 if you use the 0 as well. Then you just substitute from your special triangles or using your calculator. Then you get root 3 over 2 times negative root 3 over 2 times negative 1 over negative 1. And that gives you negative 3 over 4. 3.4, normal reduction formulas. 90 minus, first quadrant, but it's 90. So it's co-function. Therefore it becomes cos theta. 180 minus, that's second quadrant, tan, so it's negative tan theta. The cos of a negative is positive cos theta. Sin in the third, negative sin theta. Okay. The costs cancel out. The negatives cancel out. So what I'm left with is basically tan divided by sin. But tan is actually sin over cos divided by sin over 1. And I specifically put this in here when I did it with the Afrikaans class because I told you guys many times, don't have a fraction within a fraction because that's when it gets confusing. So I take the fraction, divide by whatever it is there, write it separately because then you can change it to the multiplication and swap it around correctly so that your sins cancel out and you end up with 1 over cos. Then we go on to the identity. Identity has to be exactly. Okay. If it's 1 plus sin squared, it's not cos squared. If it's 1 minus sin, it's not cos. Okay. It must be exactly as it should be. So if you look at that question, there are no identities there. Nothing. Which brings us to what we did in class over and over and over again, is your fractions. Right. Get a common denominator, you just put them together. What you do at the bottom, you do at the top. So that 1 just multiplied with 1 plus sin theta, that cos had to multiply with cos, and then you get cos squared. Now, here was the only little trick, if I can even call it that, but it was easy to just sidestep the trick as well. But what I did want you to see here, do you remember that sum that we did in class where we had sin squared theta here and then something happening in the middle and then the cos squared theta there? And then we had to see, okay, although they're not next to each other, they can become one because of the associative law, and the commutative law that they can move around. Now, if you look at that, do you see there is a 1 minus cos squared, which is sin squared. So you've got sin theta plus sin squared theta. The way you could sidestep that is maybe if you didn't see, you can substitute cos squared theta with 1 minus sin squared theta. Right? But then you had to remember that that negative has to multiply in, so it becomes 1 minus 1 and sin theta plus sin squared theta. Okay, so that's just got another hurdle if you had to use that one. Now looking at that, I want to get tan. So I want to get sin over cos. I want to get sin over cos. I already have the cos there at the bottom. So I want to get rid of that 1 plus sin. What I'm going to do is I take out a sin in common, and the 1 plus sins cancel out. I'm left with sin over cos, which is tan. So I asked the Afrikaans class, if I told you that we'll rewrite the test, not the same test, we'll write another analytical and trigonometric test on Thursday, would you do better? Why? Why? What did I explain to you today that I haven't explained to you previously? Nothing. And that is what I'm trying to tell you. Your future is in your hands. No one else's. This looks like the old question papers without the tricks in it. It's just the easy questions. Okay?